Hi scientists, this is your recording for Module 44, which is Thursday or Friday, December 10th or 11th of 2020. Um, we always start with the warm-up, so I highly encourage you to pause the video now and complete this warm-up, and you have unlimited attempts, so if you don't get them all correct the first time, try it again. Use all your resources. This is a tough one, and it's a review of what we did in Module 43. So if you didn't do Module 43, you shouldn't be watching this video. Go back and do Module 43. All right, so I hope you got an 8 out of 8 on your warm-up. So what we're going to learn about today is plate tectonics. And what that means is we are going to explore the forces that cause changes to the Earth's surface, like earthquakes and volcanoes. So you've been seeing a volcano on my screen every day. You might be wondering, what causes volcanoes to explode? So we're going to take a look at some of the forces that cause not only volcanoes, but earthquakes, mountains, oceans, all the things on top of the Earth's surface. So I like to start these classes by looking at the map that shows earthquakes that have happened today. So there's always earthquakes that happen every day on Earth, and each of these dots shows a different earthquake that happened in the last 24 hours. Some are big, some are small. None of them are really big enough to do any damage. Even this one here, we probably won't hear about it in the news, although people in Taiwan probably felt that one. All right, so, the other thing that I should mention is that most of these earthquakes are touching or near one of these red lines. And these red lines, of course, are the tectonic plates of Earth that we're going to learn about in detail today. So join me on this page, Plate Tectonics. This page has your notes. You already have these notes. Again, we started these notes in Module 43, so if you did not do Module 43, you shouldn't be watching this video. You're going out of order. So find these notes in your Google Drive by searching Plate Tectonics and pull up notes, copy of notes for Plate Tectonics. In Module 43, the last class, we talked about the chemical layers and the physical layers of Earth. Today, scroll down, you'll see a nice diagram showing all these different layer names. And underneath that, we're going to start here with making things move. All right, and so since we are using the same slideshow, I'm going to start us at slide 6. If you want to skip ahead to slide 6, then you can follow along, or you can just watch. So, what causes Earth's surface to change? So here's an image showing how Earth's surface changes constantly. At one point, all the land on Earth was connected. Actually, at many points throughout Earth's very long history, all the land on Earth has come together several times in what we call supercontinents. The most famous supercontinent, which is shown here, splitting apart, it was called Pangaea, which means all Earth. Pan means all, Gaea means Earth, so all Earth. So all the continents on Earth were once touching, and slowly over time they split apart. The next slide has a pretty cool video. It's a little bit longer, it's 6 minutes. You can watch it on double speed if you want to. It shows lots of changes that have happened throughout Earth's history, but since this is a video recording, I'm just going to skip it, but I do think you should watch it. It's interesting. Oh, it's trying to play. All right, so let's talk about how things move on Earth's surface. Well, the mantle of Earth is kind of like a lava lamp. You know how a lava lamp has globs of glowing, gooey stuff, and they break off and they float up to the top, and then once they're at the top, they slowly sink back down to the bottom, and that whole pattern starts over. Well, that is also happening inside the Earth's mantle. So remember, the mantle is a flexible part that flows slowly. So fill in the blue lines in your notes. Hot rock at the bottom of the mantle rises to the top. Heat rises, okay? And it cools down and then sinks in a pattern known as convection currents. So if you see in this GIF, we have lots of different currents or circles cycling around in the mantle. These are known as convection currents. The same thing happens in the ocean. It also even happens in the atmosphere. Convection currents are very common in many different situations in the universe. All right, a couple more blanks. The heat that fuels this process comes from the core, which is about 5,000 degrees Celsius. The core of the Earth is actually hotter than the surface of the sun. That's right, the inside of Earth is hotter than the outside of the sun. You believe it or not. So it's got a lot of heat that is a fuel source like a stove for this. Now, again, we have a video here that shows convection currents. I highly encourage you to pause now and watch it. It's a good video. It's a very interesting experiment to see, and it's short. Again, I added a lot of videos and pictures today so you can see some moving parts. Pause now and watch this video. It's less than a minute long, and it shows Earth's moving parts in the mantle. All right, so let's talk about tectonic plates. The outside of Earth is kind of like an eggshell, but it's a cracked eggshell. It's not one solid piece. So the rigid crust of Earth is broken up into 15 tectonic plates. That's what we call them. So each of these lines represents a crack in the Earth's crust, the outline of a plate. There are some big plates like the Eurasian plate, and the African plate, and the Antarctic plate, the North and South American, the Australian, and the Pacific. So there's some big plates, and then there's some small plates, some minor plates. And that would be like the Cocos and Caribbean and Nazca and Arabian and Indian. So in total, there are 15 tectonic plates. Now I want you to look at this map, find where we live, where is Indiana, and figure out what is the name of the tectonic plate that we live on. Think about that. All right, types of plate boundaries. So what is a plate boundary then? A plate boundary is anywhere that two tectonic plate edges meet. So basically all of these lines are plate boundaries. The space in between the lines, those are the plates. The lines themselves, they represent where the plates meet other plates. That's a plate boundary. And we're going to talk about 3 types today. The first type we're going to talk about is a divergent plate boundary. And this type of plate boundary is where 2 plates are moving in opposite directions. They're moving away from each other. It's like they're leaving a space there. Well, that space isn't going to leave a giant crack in the Earth. Most of the time it's going to get filled in by new rock forming from magma. And if you remember from our different types of rocks, that would be igneous rock forming there. Now, this can have a lot of results. A divergent plate boundary moving away can form a lot of things, including earthquakes, volcanoes, new ocean floor. So there's actually new oceans being formed at divergent plate boundaries, and something called a rift valley, which I'll show you in a second. One very good example, which is being shown in this picture right here, is the Mid-Atlantic Ridge. So going from the top of the Atlantic Ocean near the North Pole all the way down to the bottom of the Atlantic Ocean, 2 plates are moving apart. And the Atlantic Ocean is literally getting bigger. And that place in the bottom of the Atlantic Ocean is known as the Mid-Atlantic Ridge. Basically, this is what's happening down there at the center of the Atlantic Ocean. Here's two pictures that show what divergent plate boundaries can create on Earth's surface. So what I was just talking about, the Mid-Atlantic Ridge. Here, if we could drain the oceans, this is what we might see. It kind of looks like a very long mountain range. In fact, that's technically what it is. It's a very long mountain range, except it's under the ocean. So this is an example of new ocean floor forming at the bottom of the Atlantic Ocean. Over here, this is a rift valley. So here's two places that used to be connected, two chunks of land, two continents that used to be touching. And here's the line that separates them. Well, this is the Red Sea. And these two continents pulled apart. Maybe there was a crack there at one point, and eventually it filled in with water from around it. Now it's a big sea. So this plate is moving this way, and this plate is moving this way, and they are spreading, and we would expect this sea to grow bigger over time. All right, I'm going to pause this video and start a new one so I don't run out of time for our next two types of plate boundaries.